Good morning, dear students. In the last class, in the physics, we studied about the motion chapter. In that, we discussed about the what do you mean by the motion. Okay. So and also we wrote the definition of the motion. So the next concept in this chapter is distance traveled. What is distance traveled? So what is distance traveled and what is displacement? Distance traveled and displacement. So both are seems to be the same, but it has lot of difference. Okay, we'll see what is the difference is. So now here uh, here I have, see here, this is the path, this is the path I have here. Okay, so suppose this is the one of the path. So this is the road, here A, here B, here C, here D, and here F. Suppose we want to move from A to F. I want to move from A to F. Suppose I am standing in the place of A. Now I want to move for F. So usually how we will travel? So we'll travel like this. Actual path. What is the actual path of this A to F? So actual path of this A to F is this. So we need to go for start from A, then we need to go for B, then from B you need to go for C, from C you need to go for D, from D you need to go for F. This is the actual path. And one more path is there. So what is that path? So from A to F we can move. We can move from A to F directly. This is the path. Okay, now here we have the what is the distance and displacement. So distance is, so the first what we moved, so from A to B we moved, from B to C we moved, from C to D we moved, and from D to F we moved. So this is the actual path. So what is distance traveled in the sense? So distance is nothing but the actual path traveled by an object in a time. So the actual path traveled by an object, and actual path traveled by an traveled by an object traveled by an object is known as distance. What is displacement? So displacement is the shortest distance between the initial and the final position. The actual path traveled by an object from initial to final position, from initial to final position is distance traveled, isn't? So the initial to final position, what is the actual path is traveled by an object or any body, is nothing but distance. But the displacement is nothing but an a shortest distance, a shortest distance, a shortest distance between initial and final position. So here in the both the case, here in the blue color and the red color, I started from A and ended at F. So which is the shortest distance? So A to F I travel directly. That is the shortest distance. This shortest distance is nothing but displacement. So the actual length, the longest path traveled by an object is nothing but distance. I hope all of you understood what is the difference between displacement and distance. Okay, so actual path traveled by an object is known as a displacement, sorry, distance, and the shortest distance between initial and final position is displacement. So we can tell this is a scalar quantity. Scalar quantity. What do you mean by scalar quantity? The word seems to be new, right? So scalar in the sense, So any any of this distance or displacement, it has only the magnitude. So we can measure the we can measure the distance, but we can't say what is the measure, or what is the which direction it is moving. For example, Sita travels 5 kilometer per hour. Okay, first statement, listen this: Sita travels 5 kilometer per hour. Second statement, Sita travels 5 kilometer per hour towards north. What is the difference between these two statements? So in the first statement I told only the magnitude. So I told that she can travel 5 kilometers, or she can walk 5 kilometers per hour. But in the second statement I told that she can walk 5 kilometers per hour towards the north. In the second statement I gave the direction. So where she is moving. In the first statement, can you tell? She can tell only she can travel, she can walk 5 kilometers. But can you tell where she can travel, which direction she can travel? Are you able to tell that? No. So that is, what is it? We can so that distance is a scalar quantity. Scalar quantity in the sense it has only magnitude, so no direction. So this displacement is a vector quantity, so it has both magnitude and direction. So this is vector quantity. So this is scalar quantity and this is vector quantity. Distance is a scalar quantity, displacement is a vector quantity. I hope all of you understood this. Okay, so in the homework book you write that what is the difference between distance and displacement. What is the difference between distance and displacement? You write that. Okay, and write this in the points book. Okay, so don't want homework, so first write in the points book. I'll let you know when you have to keep the homework book. Okay, next in this, hello, so see here, we know the next write this in the write this question answers in your uh, classwork book. So keep 200 pages short book or king size book for physics classwork. So mention today's date and day and start writing this first question. An object has moved through a distance. Can it has a zero displacement? If yes, support your answer with an example. Yes, this is zero displacement is possible if any object has moved through a distance. Suppose a body is moving in a circular path and start from point A and return back to the same point A after completing one revolution. Then the distance will be equal to the circumference, where the displacement will be zero. So what they're telling here, so is the displacement is if an object travels. Suppose this is an object travels. Suppose here this is the circular path. So this is from A and this is B. So this concept you already learnt in your previous grades. So from the point A it will start. From point A it will start and will again come to the point B, point A. It will complete one revolution. So then this a total distance traveled is nothing but what is the circumference of circle. But what is the displacement? So displacement is zero. Why it is zero? Because it start from A, isn't, and it end from A. So what is the displacement? So it's the shortest distance between the initial and final position. Initial position is A, final position is A. So therefore A minus A is 0. So that only they are telling here is this is possible if an object has moved through a distance. Suppose a body is moving in a circular path and start moving from a point A and return back to the same point A. After completing one revolution, the distance will be equal to the circumference, while displacement will be 0. Okay, next question. These questions are there in your textbooks. So this is the question number 2. So which of the following is true for displacement? It cannot be 0. Its magnitude is greater than the distance traveled by the object. So for this, none of A and B are true. So why? Because so here which of the, it can't be 0 for displacement. It can't be 0. Yes, it can be a 0. It can be a 0. So its magnitude is greater than the distance traveled by the object. So no, I think why? Because displacement is the shortest distance, so the actual length is longer, it is shorter, so therefore it is not possible. Okay, so the remaining thing, uniform and non-uniform motion, everything we'll see in the next class. Okay, so copy this in your classwork, these two questions. Okay, and write see this copy this in your points book. Okay, so the remaining thing we'll see in the next class. Okay, have a nice day, bye.